Okay, hello everyone, and welcome to another episode. So today is finally the day that when AMC 12A and 10 is over, and now we're going to be explaining the 2021 fall AMC 12A problem 21. So we have that ABCD being isosceles trapezoid with BC, which is this sentence, is parallel to this sentence. And what we want to find is we want to find the area of this entire quadrilateral. Well, seems pretty tedious, right? But actually, all you want to do is you just want to draw the diagonal of this. Sorry for the bad drawing, but that's like how I draw. So now, first we can see that since this is the bisector of the perpendicular bisector of this of AC, then we can see that these two are the same length. And we can see that this is also equal to this and this is also equal to this because of the given condition that this is isosceles trapezoid. So we can see that this is actually a cyclic quadrilateral. And now we can just use angle tracing here. So let's set this equal. So this angle, we can see that this angle is clearly congruent to this angle, right? Well, since this angle is congruent to this angle, then we see that since they are all the same length, then well, this is congruent, right? So this is congruent to this angle. And actually, this makes sense because this is a cyclic quadrilateral. So when we have a cyclic quadrilateral, then we have the diagonal. Then we can see that this angle is congruent to this angle, and this angle is also congruent to this angle, right? So now I'm just going to get rid of that one, and now let's continue to proceed. So now you can see that this angle is congruent to this angle, and now what can we come up with? So we also know that this angle is congruent to this angle. So these angles are all congruent, which this angle is also congruent, right? So you see that this angle is also congruent to this angle because we're just using the same property again and again. So now a really important discovery has been out that this triangle is congruent to this triangle, which is also congruent to that triangle. So we can see that triangle, well, let this be y, which is obviously y. Then we have triangle BCY is congruent, similar to triangle CDX, right? Well, now, what we do is that, well, let's just label it out. So we know that triangle BCY is congruent, similar to triangle DCX. So now everything just becomes really clear. Now let by be equals to x. So if this is x, then this is 2, then this is the square root of x squared plus 4. Even though this is kind of extraneous, so we just want to find this sentence. Well, this sentence is clearly square root of x squared plus 16. And this is the same thing. This is still square root of x squared plus 16. This is still the square root of x squared plus 16, since they're the same sentence. Well, now, we see that this is 2 and this is x, and well, this, when we break out the Pythagorean theorem, you get this is equal to the square root of x squared plus 7. So now we just break out a similar triangle. So we can say that x over 2 is equal to what? So x over 2 is equal to square root of x squared plus 7 over 3. So we get 3x is equal to 2 square root of x squared plus 7. Well, when you see radicals, then a really common technique is to get rid of the radicals. So we can see that 9x squared, let me drag these things down. You can see 9x squared is equal to 2 times, no, we square this, you get 4x squared plus 28. So we get 5x squared is equal to 28. and x squared is equal to 28 over 5. Well, actually, now when you see this, you can have a pretty good sense that the answer must be C or E, since there's an involvement of 7, square root of 7. So now let's continue. So now we have this, right? You got the x squared is equal to 28 over 5. Then we can see that the area, let me close it up. Well, what's the area of ABCD? Well, the area of ABCD is just equal to 3 times 3x plus 3 times square root of x squared plus 7. So that is the thing that we want to find out. So now let's continue to solve this. You can see that, so we first want to find the square root of x squared plus 7, so we can say that x square root of x squared plus 7 is equal to the square root of 53 over 25. Right. After solve this, or just rationalize 3 root 7 over root 5, no, over 5, which is just equal, yeah, which is just this answer. No, so actually it's 3 root 7 over root 5, which is 3 times the square root of 35 over 5. Right? Now, well, x is just equal to 2 times the square root, no, so it's 2 root 7 over root 5, which is equal to what? Which is just equal to 2 root 35 over 5. Now you plug it back in, then we can see that this is basically just equal to 3 times 5 root 35 over 5. Let's cancel out, gives us answer choice C. Thank you for watching, have a great day, and see you next time.